Welcome to quadratic functions. A quadratic function is just an arch. Essentially, it is a graph that is shaped like the letter U. It can be right side up or it can be upside down. We talk about the vertex of a quadratic function. The vertex is just the xy coordinate where the line changes direction. If the line makes a right side up U, it will have a minimum value. This is because the leading factor A in the equation is positive. If the equation makes an upside down U, that is said to have a maximum value. The reason is that the leading factor A is negative. Talking about quadratic functions, we sometimes talk about something called the axis of symmetry. This is just a vertical line that's drawn through the exact middle of the graph. It goes through the vertex. If you have a vertex that's located at 3, 5, then the axis of symmetry is x equals 3. The axis of symmetry is always an x equals a number equation. You can get some clues to things just by looking at the equation for the function. These equations are in vertex form. F of x equals x squared. This is called a parent function. The vertex is 0, 0. If the equation has no parenthesis and looks like this, f of x equals x squared plus 2, the vertex is 0, 2. No parentheses means the x value is 0 at the vertex, and the minimum or maximum value for y is going to be whatever the other number is. Vertex form equations can become a bit more complicated looking. If the equation has a set of parentheses with x plus or minus a number, and that quantity is squared, it can look like these. F of x equals the sum of x plus h squared plus k. Or if I were using numbers, f of x is equal to the sum of x plus 2 squared plus 3. To find the vertex, you always use the opposite of the h value inside the parentheses for x and the number that is given for the k value outside of parentheses for y. Looking at the equation I have here, f of x equals the sum of x plus 2 squared plus 3. H is positive 2. That means x is negative 2 at the vertex. K is positive 3. So the y value at the vertex is positive 3. It's as simple as that. When you transform something, you change it in some way. This is looking at rigid transformations of a quadratic function. It means you are not changing the shape of the function or line. You are only changing where it is on the plane. And it's relatively easy to do. You rewrite the original equation, but with different combinations of positive and negative. If you look at these 4 equations, the first equation has positive 2, positive 3. The second one has negative 2, positive 3. The third one is positive 2, negative 3. And the fourth one is negative 2, negative 3. This moves the graph either left or right or up or down but it does not change the shape of the graph. These are rules for very basic transformations. When you change the sign inside the parentheses, the graph moves left or right from the original location. When you change the number outside of the parentheses, the k value, then the graph will move up or down on the y-axis. Remember, these are basic rules. When you change the number inside the parentheses, it is a little bit more complicated. Okay, some quick examples of what it means to have transformations at work. If I have the equation f of x equals x squared, this is called the parent function. The vertex is at the origin, 0, 0. If I change that equation and say f of x equals x squared plus 4, the function has transformed and the vertex is now 0, 4. The x value or placement did not change, but the vertex moved up 4 places on the y-axis. Move the transformation left to right. Look again at the parent function, f of x equals x squared. The vertex is 0, 0. I'm going to change this function, and I'm going to say f of x equals the sum of x plus 2 squared. The function transforms, and the vertex is now -2, 0. The x value changed to -2, but the y value stayed the same. The vertex moved 2 places to the left on the x-axis. Okay, now we're going to make a transformation where we move both left and down. The parent function is still f of x equals x squared, and the vertex is 0, 0. The new function reads f of x equals the sum of x plus 2 squared minus 3. The new vertex is -2, -3. The vertex moved 2 places to the left on the x-axis and 3 places down on the y-axis. The shape of the line did not change, but its location on the graph changed. Summarize. Quadratic functions are right side up or upside down, arches, letter U, whatever way you want to think about it. The vertex is the x and y coordinate where the line changes direction. The minimum is the lowest point before it changes direction. The maximum is the highest point before it changes direction. The axis of symmetry is just a vertical line drawn through the very middle of the graph. It goes through the vertex, and it's always written as x equals the x value of the vertex. That's it.